This is my implementation for the paper physically based real-time lens flare rendering, and I've done this implementation using John Chapman's pseudo lens flare. The implementation is broken down into three steps. First is the downsampling. Downsampling helps in reducing the cost of the following stages and helps us select the brightest pixels in the image. These bright pixels are then used for generating the lens flare artifacts. Second is generating the lens flare artifacts. There are different artifacts such as ghosts, halos, and chromatic distortion. Ghosts are repetitive blobs that mirror the bright spots pivoting around the image center. Halos are the circular patterns around the bright spots, and chromatic distortion is an optical aberration obtained by varying the refractions of different wavelengths of light. Since the ghosts retain the appearance of the source image, I have made use of the Gaussian blur, which is a popular image processing technique to smooth out images. Gaussian blur was helpful as it reduced the high frequency and noisy details from the image. So this is the final lens flare which is achieved from the frame buffer code, and there are certain parameters that we can change, such as the scale and the bias for downsampling or thresholding. And then we have ghost parameters, which are the number of ghosts, the dispersal, and the weight. Third is the halo parameters, which is the width and the weight. And then is the distortion parameter, which is the chromatic distortion for the color. And then we can switch on and off the blurring for the lens flare. So first I'll change the scale value, and as I go on increasing it, we can see that it becomes really bright. And I'll just turn the bias down to 0, and when we reduce it to 0, we can see that it becomes really dark. Next, I can change the ghost parameters from up to 1 to 20 just for testing, and we can see that as the number of ghosts increase, the size of the ghosts also increase, and reducing it makes the size decrease. So I'll keep it down to 2. Next, I can change the dispersal amount of the ghosts, and as I reduce it, we can see that it disappears completely, and on increasing it, the size increases. Then I can change the weight, which determines how much spread out I want the ghosts, and here it is completely spread out, and here it is more strong and crisp. Next is the halo parameters, where I have the width and the weight, and here I can change the size. When I reduce it, it becomes smaller, and it becomes larger on increasing it. Next is the weight, how much dispersal I want in it, and I've just kept it to strong, which is really crisp. Next is the chromatic distortion, which changes the color of the chromatic. You can see it changes it to green, red, blue, and then back again to green. And I can add the blurring on the lens flare. Furthermore, I can also move around the scene, and we can see the lens flare doesn't show up on most of the places which are not that bright. So I have this one bright spot, which is the red one. We can see that's generating the lens flare for it. Similarly, other places are not that bright, so there's not a lot of lens flare which is being generated. Over here we have the reflection from the sun coming on the water, so it's generating the lens flare. This portion is being repeated by the ghosts, so that's the ghost parameters. And then I also have occlusion in the lens flare, where when the lens flare is behind a solid object, it gets cut off like a semicircle. So you can see as I'm pointing away from the lens flare, it's completely disappeared, and when I'm partially on it, it generates semicircle halos. This is due to the halo parameters. And I can also change the width for it.